child eat or drink? In that, does the child, the mother, for example, eat or drink? Not a fluoride. We can find here fluorapatite. Fluorapatite crystal. Why is it better, the fluorapatite? Or the tap water contains how many milligram? It's important normally. What would be the normal fluoride contained in the tap water? 1 ppm, 1 milligram over liter. In that situation, not hydroxyapatite is developing, but fluorapatite. Hydroxyl group exchange with fluoride, and fluorapatite is much more stronger, harder, and smaller crystal, because of it is more compact, smaller crystal. And it is the interprismatic enamel which produces which part of the Thom's process? Interprismatic? Laterally part, yes. Not so hard, not so strong, a little bit, you can see confused of the crystals. Here you can see interprismatic enamel. A little bit softer, and we can find here between the prismatic and interprismatic prism sheet which contains organic material, because the enamel contains only how many percent organic material? 1. Yes, 98% inorganic. And but at first, when the ameloblast produces enamel 30%, but later there will be a mineralization. 96-98 inorganic, 1 or 2% water, and 1% organic material. So at first, producing ameloblast, the primary enamel, which contains 30% inorganic material, but it needs to reach 96-98%, so we can see the mineralization. The calcium is coming from this one ameloblast. It's coming from the capillary network, and through the intercellular material, through the stellate reticulum cells, stratum intermedium cells reach the ameloblast and deplete through the Thom's process with exocytosis. But this is an active transport, not passive but active transport. There are some kind of calcium pumps and push it towards the enamel, the calcium, a lot of calcium. Deplete calcium with secretory granules, or we can find calcium freely, but much more in secretory granules. But this system is active system with active transport. Here you can see the active transport, passive diffusion. Mainly we can find active transport here. Here you can see the calcium concentration with the Thom's process, one ameloblast, stratum intermedium cells, and through these cells calcium reach the enamel. So again, you can see here the two types of enamel, the prismatic, producing by the distal part of the Thom's process, and interprismatic, the dotted. It's not so hard, not so strong. Again, here histologically, these are the secretory granules, and prismatic and interprismatic enamel. And between them, prism sheath. It has a keyhole structure. The prism, this is the interprismatic, prismatic enamel. The head is prismatic, the tail is interprismatic, and covering the root sheath of the head. which I didn't tell you, that ameloblast producing different types of proteins, but the main type is amelogenin, enamelin, and ameloblastin, or tactilin. But what happens with amelogenin during the mineralization? You remember? No? We didn't learn in biochemistry amelogenin. Disintegrate, yes, by enzymes. The ameloblast producing some kind of enzyme. And the other route is very important. The ameloblast has again two types in the relation of mineralization. One is smooth-ended, one is ruffled-ended. It's after the producing the enamel structure during the mineralization. Again, we can see two types of ameloblast: ruffled-ended and smooth-ended. What happens in relation of ruffled-ended? It depletes a lot of calcium into the enamel structure, and because the amelogenin is a isotropic material, it's flowable under pressure, and because of the pressure of calcium, it disintegrates the amelogenin, and in the other form, smooth-ended, it withdraws to ameloblast the protein, remnants of amelogenin, and the water. And during this mechanism, we can find much more and more calcium content of the enamel structure. And you can see here, in this situation, in relation of ruffled-ended, the distal terminal bars close. So calcium only can go through the cell, through the cytoplasm of ameloblast. But when withdrawn water and protein towards the ameloblast, its opening but closed the proximal one. So it can go through the cytoplasm and through the intercellular material. What do you think? Why is it important, this ruffled end, ruffled border, ruffled end, in relation of the depletion of calcium? Why is it good, the ruffled border, ruffled end? Surface, much more higher surface, yes, than this one. It has a much more higher surface of the cell. These are part of the cell, and it's very important to deplete a lot of calcium toward the enamel structure. These are stratum intermedium cells. So sometimes we ask in the exam, please let's say how many types of secretory and ameloblast do you know, and how many types ameloblast during the mineralization? The correct answer, the secretory ameloblast without the Thom's process, with Thom's process. And answer of the second part of the question, in relation of mineralization, ruffled-ended ameloblast and smooth-ended ameloblast. And after it, sometimes we ask what happens in relation of ruffled-ended, what happens in relation of smooth-ended during the mineralization. Depletion of water and protein in relation of smooth-ended through the cells and between the cells, and in relation of ruffled-ended calcium, depletion toward the ecophytosis toward the enamel structure. And during this mechanism, it reaches the 96-98% inorganic content of the enamel matrix. Which type of proteins remain in the enamel?